Hi class, welcome back. So today we will get started by talking about the force system. So before we get started, let's do some quick review of your previous physics knowledges. So my first question is, if I'm giving you a vector force vector F and also one point A, so we know the moment of this force, the 12 Newton force, what will be the moment of this force about point A? So I believe this is something already discussed in your previous physics class. So the moment will be the distance between to be more specific, the perpendicular distance between the one point to the action of the line of the force. So we can say from the distance from the force F to the point A is 3 meters and times by the force magnitude. So answer will be 3 times by 12, which will be 36 Newton meter. Okay, the answer should be B. Okay, if you are not familiar with those things, so please pause this video and do a very quick review of your previous physics knowledge. So my second question, what's the moment of force F about point O? That's how we calculate the moment. Okay, so the answer C is a dot product between the vector R and F. As we discussed already before, we use a dot product to find the angle between two vectors. So answer will be definitely not C. And D, okay, we don't have such thing in this class. So the answer will be either A or B. So as we mentioned before, we use a cross product can be used to calculate the moment. So should we put the R vector first or should we put the F vector first? So answer should be A. Okay, we always put the R first to represent the moment. Okay. So I think those two questions are pretty straightforward for you. So what's the moment? So let's say we have B and we have the force F, and there will be some deformation of the beam. So the force causes the beam to bend a little bit, and that's where we describe the moment. Okay, so because the beam it bent a little bit, so that's because of the moment. So the moment, by definition, it provides a measure of the rotation. Okay, a measure of the rotation of a point caused by a force. Okay, let me write the definition down. Provided by the measure of okay. Here's the definition. And the equation to calculate the moment will be cross product between the direction and the force vector. Okay, let me show you one more example. Let's suppose this is a beam. As you already know, the distance should be the perpendicular distance between the point to the action line of the force. So for example here, if the force is perpendicular to the beam, its moment will be just MO equals to D times by the F. And however, if here is O, here is F, okay, here is the distance A, here is distance B, how could we calculate the moment? So to calculate this, okay, let's resolve the F to Fx and Fy. The answer will be Fy times by its perpendicular distance to the point O, which is A, and the Fy, its movement on point O is counterclockwise. Okay, so for this class, we define a counterclockwise movement as a positive and a clockwise movement as a negative. And Fy times by its perpendicular distance to point O will be the B, because the Fx, the force movement on point O, is clockwise, it will be negative. So that's how we calculate the movement of the force F on point O. Okay. So let's see an example. Suppose we have a 100 Newton force is applied to this frame, and the moment, please find the moment of the force on point O. As you already see in my previous example, so we need to first resolve the 100 Newton force to X and Y axis, and then we can determine using the scalar analysis for the two force component and then add those two moments together. So Fy, it will be 100 times by 3 over 5, and it will be negative. And Fx will be 100 times by 4 over 5, and it's positive. For the moment, for the Fy, the force Fy cause the frame on point O to make some clockwise rotation. So that's why the Fy's movement, Fy force on point O its movement is negative. And the similar for the Fx, it's also Fx movement on point O is also negative because the rotation is clockwise. So that's why we put 2 negative here, and we sum this together, it will be negative 460 Newton meter. And the direction is counterclockwise. Oh, sorry, the direction is clockwise, okay, because it's also negative. Okay, let's see one quiz. So if the force of the magnitude F can be applied in four different 2D configuration, PQRS, select the case resulting in the maximum and minimum torque value on the net. So answer will be D. Okay. Why? So why the vector on the x direction is minimum? Because the vector, the force if the force is acting on the x direction, which means the distance between the point to the force action line is 0. Okay, because the point just on the action line, which is 0, which means the torque will be 0. So this is the minimum. And for the Q, because we always calculate the perpendicular distance. Okay, if the force is working on the direction of the Q, its distance is biggest. That's why a Q has a maximum torque. So what about this one? If moment equals to r cross vector of f, what will be the value of m times dot r? Okay. As we discussed before, the moment vector is always perpendicular to both vector r and f. So vector m and r is if it's perpendicular, its angle will be 90, and m times r equals to magnitude of m times by magnitude of r times by cosine theta. Because it's perpendicular, theta will be 0. The theta will be 90. The cosine 90 will be 0. Okay, that's why the answer will be A. Okay, let's see another problem. So we have 20 live force is applied on a hammer. What will be the moment of the force at point A? So for this problem, similar we first need to resolve the force into x and y axis, and then determine m moment using a scalar analysis. So Fy will be 20 times by cosine 30, and Fx will be 20 times by cosine 30. So the Fy, the force, its movement on point A is moving the hammer clockwise, which is negative, and for the Fx, it's also moving the force clockwise, is also a negative. So that's why I have two negative here. So here is the final answer. Okay, here is the attention quiz for today. Using the counterclockwise direction and positive, the net movement of the two forces above point P is, so for the 5 Newton times by 2 meter is 10 Newton meter, and it's clockwise, it's negative, and this one is 10 Newton times by 3, it's 30 Newton meter, and because this one is counterclockwise, it's positive, V plus is together, the answer will be B. So let's look at another question. If the direction vector is 5g, the force vector is 10k, the moment of the r cross product of f equals to, okay, so the answer will be, because the direction vector is just on the g direction and the force vector is just on the k direction, its cross product will definitely be on the I direction. So that's why C, D, E, they are all wrong answers. Sorry, B, D, E. So will that be positive 50 or negative 50? So because the cross product is from R to F, it will be from G to K direction. So if we use right hand principle, it will be force, the new product will be towards the positive direction of the I. So answer will be A. So well, that's pretty much for today's lecture. We will talk about the force on axis from next lesson.